challenges. The project is co-chaired by Stephen Matlin from Imperial College in London, who's also been very involved with the International Organization for Chemical Sciences and Development. And we sat down and we asked about 24 leaders in chemistry education around the world whether they would join this project. And 24 people said yes. So here's a list of the IUPAC project team. And what I'd like to do today is to start and give you an idea of what we've been able to accomplish in a year and a half and what some of the next steps are. We began by going to the literature, and this work was published in Nature Reviews Chemistry a year ago, and develop a framework for systems thinking and chemistry education, learning from what other disciplines, particularly engineering, but the geosciences have done. And it's a framework for systems thinking and chemistry education. So we place learners, students at the very beginning, the middle of that framework. And then we identified 3 subsystems, or 3 nodes, 3 elements of that framework. And the first is learner systems. So what are the general things that we know about learning, the theoretical frameworks of learning, learning progressions, the social context for learning, an important element in a framework for systems thinking and chemistry education. And secondly, how do those general understandings of learning apply to the very unique challenges of understanding chemistry, the world that of molecules and atoms that we can't see directly, full of models, full of mathematical relationships. And then finally, how might that system, the third node is the Earth and Societal Systems node, how might that apply to chemistry education as it relates to meeting social, societal, and environmental needs? One of the important outcomes has been a special issue of the Journal of Chemical Education, one of the 2 leading journals of chemistry education in the world. And we have a special issue which will be published in November or December of this year. And we thought we might have about 20 authors coming together to begin to understand the idea of systems thinking and chemistry education. And we received about 70 contributions to the paper, to the special issue. So look for this when it comes out. And the new incoming editor of the Journal of Chemical Education is on the project team, Tom Holm. So progress to date. Let me just summarize what we've done and then pick a few things to talk about a little bit in more detail so that you have a concrete idea of what systems thinking and chemistry education might mean. We had to start by defining systems thinking and defining systems thinking and chemistry education. What's the purpose? What's the framework? We did a systematic review of systems thinking in other fields so that we could understand what we might learn from what other fields have done. And of course, one of the challenges in education of showing students the whole is complexity. So what pedagogical strategies do we have to deal with complexity? Skills and competencies for systems thinking. Tools and visualizations to help educators and students do systems thinking. And then how can we use systems thinking to address global challenges? And what learning frameworks can we use to develop this new area in chemistry education? We're also very interested in knowing how organizations that are responsible for education in different countries and regions, like accreditation agencies, standardized examinations, to bring them on board with this new idea of systems thinking in chemistry education. So I'm going to pick 3 of these and just talk a little bit more about progress in these areas. First of all, skills and competencies. And we've learned here from work that's been done in the earth sciences to take the different elements of systems thinking and to develop a little bit of a hierarchy, a pyramid, where at the bottom, what we'd like students to be able to do is to see the whole but analyze the system components. And then a series of activities, of skills and competencies that involve putting those together. And finally, of course, implementing, being able to apply that knowledge to things that matter. And this has been published in an early release of a paper from that special issue. The molecular basis of sustainability. This is work which has been done by the Earth and Societal Systems Group, or NODE, within the Systems Thinking Project. And that includes Stephen Matlin and myself, Tom Holm, the editor of the Journal of Chemical Education, and then two colleagues from the Green Chemistry Institute at the American Chemical Society. The molecular basis of sustainability is not a concept that we have invented, a new concept. It appeared very briefly in the literature. Paul Anastas and Julie Zimmerman at Yale University introduced the term, the molecular basis of sustainability, and they described it as saying many environmental issues have molecular considerations. We've now tried to take that important idea that was in the literature and develop it very fully in the concept of systems thinking. And so in a paper that was published in May of this year in Nature Sustainability, the ideas that we've put forward in that publication look like this. The flow of material and energy is integral to all aspects of society and the environment. What do chemists do? Our profession understands and controls matter through the activities of chemistry. And because of that, chemistry and chemistry education have a special responsibility to address the sustainability of Earth and societal systems. And so we define now the molecular basis of sustainability as the ways in which the material basis of society and economy underlie considerations of how present and future generations can live within the limits of the natural world. And the latter part of that definition you may recognize comes from the Brundtland Commission of Sustainability. And finally, the molecular basis of sustainability we think is a crucial but largely invisible aspect of sustainability agendas, and I'll give you a few examples of that. If you think about sustainability and sustainability agendas, perhaps the first things that will come to mind are some items that have appeared in the global press around the world. And one of them was earlier this spring, a major report from the United Nations showing that 1 million species face extinction. So the loss of biodiversity is one of the major sustainability challenges that we face. And perhaps the second thing that might come to mind is the data, this goes back 800,000 years, of the carbon dioxide concentration in our atmosphere. And on May 18 of this year, that concentration at the Mauna Loa Observatory in Hawaii reached 415 parts per million. This is where we are in 2018. And the observation was made in headlines around the world that that level of carbon dioxide is more carbon dioxide in the atmosphere than at any other point since the evolution of human beings.